Dear students, now look at the example problem 9.2. Three equal masses of mkg each are fixed at the vertices of an equilateral triangle. What is the force acting on mass 2m placed at centroid? Second one is, what is the force if the mass at the vertex A is doubled? So the AO, BO and CO distances are asked to take as 1 meter. This is AO, this is BO, and this is CO. These are 1 meter. Now let us draw x-axis passing through the centroid. This is positive x-axis and this side negative x-axis, and let this be positive y-axis and this is negative y-axis. So the origin is taken at the centroid of the triangle. Since this is equilateral triangle, at each vertex the angle will be 60 degrees. If this is 60 degrees, this will be 30 degrees. These two are parallel to each other, and if this is 30 degrees, this also 30 degrees. Alternate angles are equal. Here 30 degrees and here also 30 degrees. Now solution of A bit. What is the force acting on mass 2m? See, this 2m mass is being attracted by mass m placed at A in this direction. See, this can be called as force on this mass placed at O by mass placed at A. So let us write this as FOA, force on O by A. Force on O by A. Similarly, this mass is being attracted by this mass in this direction, and this force is force on O by C. Here this mass is attracting this mass, so force on O by B. Now if we take sum of the three forces, we get the total force acting on 2m. So force acting on 2m is equal to FOA plus FOB plus FOC. So let this be the resultant force FR. Now let us calculate the three forces separately. Now writing universal law of gravitation for FOA. FOA is equal to capital G. So mass placed at O and mass placed at A by the distance between those two is ROA square into the force is along OA direction. So ROA unit vector. Now capital G, MO mass placed at O is 2m, mass placed at A is m by ROA. The distance between O and A is 1 meter into unit vector along ROA. See, this is in the positive y-axis. The direction of force is along positive y-axis. The unit vector along x-axis is I, the unit vector along y-axis is j, and the unit vector along z-axis is k, that you know. So here FOA force is along positive y-axis, therefore the unit vector is j. So we write this as two G m square j. Now let us find FOB. Capital G into MO MB divided by ROB square into unit vector ROB. Now MO is 2m, MB is m, ROB let me write here. Let us draw perpendicular onto the negative x-axis, here onto the positive x-axis. Suppose this is a D and this is E. Now MO, that is mass placed at O, is 2m, mass placed at B is m, ROV unit vector. How we get unit vector? By dividing a vector by its magnitude, we get unit vector. Now, but here ROV is equal to ROB divided by its magnitude. Say ROB, this vector's magnitude is 1 meter. 1 meter. That is equal to ROB. Now we have to find ROB. We get this vector. See, this is ROB vector. We get this vector by taking sum of this vector and this vector. So we write here arrow mark here and here another arrow mark here. This vector plus this vector is equal to this vector. Therefore ROB can be written as sum of ROD plus RDB. Now ROD is, see, by considering this right angle triangle, its hypotenuse is 1 meter. Its adjacent side will be 1 cos 30 and its opposite side will be 1 sin 30. So this will be 1 cos 30 and this will be 1 sin 30. So 1 cos 30, 1 cos 30 and direction is required. So this is positive x-axis means I, negative x-axis means minus I, plus RDB, this one. So this one is 1 sin 30. See this is positive y-axis, this is negative y-axis, parallel to that. So along positive y-axis unit vector is j, and along negative y-axis the unit vector is minus j. So this is pointing downward, therefore minus j. So we write here, so here this is our OB, that is equal to minus cos 30 I minus sin 30 j. So substituting these values in this, F OB is equal to G, capital G, MO is M, MO is 2M and MB is M divided by ROB value is 1 meter, ROB value is 1 meter, 1 square into, and this value is minus cos 30 I minus sin 30 j. This is second equation. Now FOB over FOA over FOB over, next is FOC. FOC is equal to capital G MO MC by ROC square into unit vector ROC. MO, mass placed at centroid is 2m, mass placed at C vertex is m, ROC value is 1 meter. Now ROC unit vector is equal to ROC vector divided by its magnitude. ROC vector divided by its magnitude is 1. Now here this ROC is nothing but sum of ROE plus REC. REC. Now again this is a right angle triangle. Its hypotenuse is 1 meter. Therefore adjacent to 30 degrees will be 1 cos 30 and opposite to 30 degrees will be 1 sin 30. Now ROE is 1 cos 30, that is cos 30, and direction this is in the positive x-axis direction, therefore I plus REC downward, and here the magnitude is sine 30 and the direction is along the negative y-axis, therefore minus j. Substituting these values in this equation, we get capital G 2m into m by 1 square into cos 30i minus sin 30j. This is third equation. This is third equation. Substituting these values, in this equation. So FR is equal to FOA plus FOB plus FOC, that is equal to FOA is 2gm square j plus FOB, here we have 2g m square minus cos 30 I minus sin 30 j. Here FOC is there, 2g m square cos 30 I minus sin 30 j. Now we can take 2gm square common plus j minus cos 30 I minus sin 30 j plus cos 30 I minus sin 30 j plus cos 30 I minus cos 30 I plus, j minus sin 30 j minus sin 30 j minus 2 sin 30 j 2g m square j minus 2 into sin 30 means 1 by 2 j, 2 gets cancelled, j minus j 0, so you are getting 0. This is one answer. Now what is the second question? What is the force if the mass at the vertex A is doubled? Here, if this is changed to 2m. So force on it is here. It is already, it is there. So here, in place of mass at A, we have to put 2m. So what we get here, let us write FOA. Second, next one. So let me write here, FOA is equal to 2g let me write this one. FOA is equal to G MO MA by ROA square ROA. Now capital G, mass at centroid is already 2m. Now mass at A is changed from m to 2m by ROA 1 meter square, and this ROA is and ROA means unit vector along positive y-axis j. 4g m square j. This is FOA. Now we have to substitute this value here. FOB, FOC, same values. Okay. Now FR is equal to FO, this value, plus these values two G m square is taken common, so here remains 2j plus here minus cos 30i minus sin 30j plus cos 30i minus sin 30j. So we get here 2gm square 2j minus sin 30j minus sin 30j minus 2 sin 30j 2gm square 2j minus sin 30 value 1 by 2 j 2j minus j. So this is second answer. Now let us do this problem. 3 spherical balls of masses 1 kg, 2 kg and 3 kg are placed at the corners of an equilateral triangle. So this is an equilateral triangle. This is A, B, C. Here 1 kg, here 2 kg, here 3 kg are placed at the corners of an equilateral triangle of side 1 meter. 1 meter, 1 meter, 1 meter. And since this is an equilateral triangle, here 60 degrees, here 60 degrees, here 60 degrees. Find the magnitude, only magnitude is required. Find the magnitude of gravitational force exerted by the 2 kg and 3 kg masses on the 1 kg mass. Force on 1 kg mass is asked. So this 1 kg mass is being pulled by this 2 kg mass in this direction, and this can be called as force on A by B. Similarly, this 1 kg mass is being pulled by this 3 kg mass, and this can be called as force on A by C. Now we have to find the resultant of the two forces. So to find the resultant of the two forces, we make use of the law of parallelogram. You have learned in Sem 1. Suppose this is force P, and this is force Q, and the angle between them is theta. Now taking these as adjacent sides, we can construct a parallelogram, and sum of these two forces, the resultant of these two forces, is represented by the diagonal, and it is given by the resultant of the diagonal is given by p square plus q square plus 2pq cos theta under root. In this way we find the resultant of these two forces. So now we follow the same thing. The resultant of two forces will be in this direction. Now the magnitude, only magnitude is asked. Therefore, Fr is equal to Fab whole square plus Fac whole square plus 2 Fab into Fac cos, here the angle between two forces is 60 degrees, under root now let us find Fab. So this is equation 1. Now let us find Fab. So only magnitude G, capital G, mass at A is 1 kg, mass at B is 2 kg, by the distance is 1 meter. So this is equal to 2g. Similarly, FAC, capital G, mass at A is 1 kg, mass at C is 3 kg, the distance between the masses is 1 meter, so this is 3g value. So substituting the values here, FAB means 2g, 2g square plus 3g square plus 2 into 2g 3g cos 60 means sin 30, that is 1 by 2 under root. So here 2 and 2 gets cancelled. 4g square plus 9g square 2 3 is 6g square under root, and that is equal to 9 plus 6 15 plus 4 19g square. So here FR is equal to, only magnitude, root 19g. This is the answer. Now look at the 10th problem. 3 uniform spheres, each of mass m and radius r, are kept in such a way that each touches the other two, like this. Find magnitude of gravitational force on any one of the spheres due to the other two. So now let us find gravitational force on A due to B and C. So here it is better to write this equilateral triangle separately here. Now we can assume here point masses are placed like this. Point masses are placed. Each mass is m, and here the radius is capital R. So here to here r and here to here r plus r 2r. So its side becomes 2r. So it becomes 2r. Now we are calculating force on A by B, and that is represented as F, force on A by B. Similarly, force on A by C. So we have to find the resultant of the two forces, and that will be along this direction. Here the angle is 60 degrees. So again we will make use of the law of parallelogram. So here only magnitude is asked. Therefore FR is equal to FAB square plus FAC square to FAB FAC cos under root. Now FAB, capital G, mass here is m, mass at B also m, and the distance between these two is 2r. That is gm square by 4r square. So FAC also same. So substituting these values, we get two into cos 60 means 1 by 2. So here FAB square, this must be squared. FAC square. Like the 2 and 2 gets cancelled. So here if we look at this term, this term and this term also same. Therefore 1, 2, 3. So it is occurring 3 times. 3 into g m square by 4r square under root. That is root 3 gm square by 4r square. So this is the answer.